Here's something you did not notice this morning. You woke up, you made coffee, you checked your phone, and the entire time you were hurtling through space at 1,040 miles per hour. Not in a plane, not in a car, just standing still. The earth beneath your feet is spinning. Right now, as you read this, faster than a bullet, and you feel nothing. Now, here's the disturbing part. What if it stopped? Not forever, not for a minute, just 1 second, 1 Mississippi. That's all it would take to end everything you have ever known. I am going to show you exactly what would happen, and I promise you, by the end of this, you will never look at standing still the same way again. Let me start with something you already know, or think you know. The Earth spins once every 24 hours. That's why we have day and night. Simple enough, right? But here's the thing. That spin is not gentle. At the equator, the surface of the Earth is moving at 1,040 miles per hour. In Ecuador, in Kenya, in Indonesia, the ground beneath people's feet is traveling faster than the speed of sound. Think about that. You are on a rock. That rock is spinning, and the only reason you don't feel it is because everything around you, the air, the buildings, the water in your coffee cup, is spinning with you. This is called inertia, Newton's first law. An object in motion stays in motion unless acted upon by an external force. You are in motion right now. You have been in motion since the moment you were born, and so has everything else. But here's the thing nobody talks about. What happens when the rock stops and you don't? Let me build this up carefully. Imagine you're on a train, a very smooth train, moving at 100 miles per hour. You're sitting comfortably. You have a cup of coffee on the table. The coffee is still. The air is still. Everything feels normal. Now imagine the train hits a wall. What happens to you? What happens to the coffee? What happens to everything that was moving with the train? It keeps moving. You fly forward. The coffee flies forward. The air flies forward. Everything that was in motion continues in motion until it hits something. That's physics. That's inertia. That's the universe's most fundamental rule. And the Earth is a train moving at 1,040 miles per hour. Now, I want to be careful here. When I say the Earth stops spinning, I need to define exactly what I mean. I don't mean the Earth gradually slows down over millions of years. That's actually happening. The moon's gravitational pull is slowing Earth's rotation by about 1.4 milliseconds per century. In 200 million years, a day will be 25 hours long. That's not what we're talking about. I mean a sudden stop, an instantaneous halt. One moment you're spinning at 1,040 miles per hour. The next moment, you're not, but you are. You see, the Earth can stop. The ground can stop. The mountains can stop. The oceans can stop, but nothing on Earth, nothing made of atoms, nothing subject to physics, nothing that exists in this universe can stop you. A 2019 study from NASA's Jet Propulsion Laboratory modeled exactly this scenario. They used supercomputers to simulate what would happen if Earth's rotation ceased instantaneously. The results were not encouraging. Here is the charge sheet against 1 second of stillness. It would create winds of 1,040 miles per hour at the equator. It would launch every human, animal, building, and vehicle eastward. It would generate tsunamis thousands of feet high. It would trigger earthquakes across every tectonic plate. It would reshape the atmosphere, the oceans, and the continents. It would end civilization in less time than it takes to blink. And every single one of these catastrophes, every single one, would happen simultaneously. Let me be honest with you. This is not speculation. This is physics. The same physics that keeps you in your seat right now is the physics that would kill you if the Earth stopped. The only difference is direction. But wait, there's more to this story, because the spin isn't just about speed. It's about everything. The shape of the planet, the distribution of the oceans, the behavior of the atmosphere, the existence of the magnetic field that protects us from solar radiation. All of it depends on the spin, and I find that disturbing. Not because the Earth might stop. It won't. Not suddenly, not like this. But because we live on a spinning rock and we never ever think about it. We take it for granted. The most fundamental fact of our existence, that we are moving, is completely invisible to us. We have built our entire civilization on a platform that is hurtling through space, and we call it standing still. Now here's where it gets interesting. What would actually happen? Not in general terms, not in metaphors, but second by second, moment by moment. What would you experience if the Earth stopped spinning for exactly 1 second? Let me take you through it, and I should warn you, what comes next is the part that will genuinely disturb you. Let me explain this the way I'd explain it to a bright 12-year-old, because when you can do that, you know you truly understand something. Imagine you're holding a ball on a string. You're spinning in circles. and the ball is flying outward, held only by the string. Now, in an instant, you stop spinning. What happens to the ball? It doesn't stop with you. It keeps moving. It flies off in whatever direction it was heading the moment you stopped. You are the ball. The string is gravity and friction, the forces that keep you attached to the spinning Earth. But those forces have limits. They can hold you to a gently rotating planet. They cannot hold you to a planet that has suddenly become stationary while you're still moving at 140 miles per hour. Let me take you through the first millisecond. The ground stops. You don't. Your feet, technically, are in contact with the ground. The friction between your shoes and the floor has been keeping you spinning with the Earth. But friction is not instantaneous. It takes time to transfer force. And in the first millisecond, less than the blink of an eye, the force required to stop you exceeds anything friction can provide. You begin to slide. No, that's too gentle a word. You begin to be launched. At the equator, you would experience an acceleration equivalent to being hit by a car traveling at highway speed, except the car is invisible, and it's hitting you from the west. Your body would begin moving eastward at over 1,000 miles per hour, while still technically standing on ground that is now stationary. The same thing happens to everything else. The air, the water, the buildings, the oceans, the mountains, or at least the loose material on them. Everything that was moving keeps moving. And here's the beautiful part. I use that word deliberately because there is something almost elegant about this destruction. Every single object on Earth would begin moving in the same direction, east. Think about it. A 2017 paper in Geophysical Research Letters calculated that the kinetic energy released would be equivalent to approximately 10 to the 25th power joules. That's 10 trillion joules, released in a fraction of a second. To put that in perspective, the largest nuclear bomb ever detonated, the Tsar Bomba, released about 2 times 10 to the 17th power joules. This would be 50 billion Tsar Bombas, all at once, everywhere. I want you to hold that number in your mind, because it's going to get worse. Now let me take you one level deeper. In the first millisecond, you started moving. By the end of the first second, our 1 second of stillness, you are no longer recognizable as a human being. Let me be precise about this. At 1,040 miles per hour, you would travel approximately 1,500 feet in 1 second. That's 5 football fields. You would cover that distance horizontally, along the ground, through the air, through whatever was in your way, in the time it takes to say 1 Mississippi. But you wouldn't be traveling alone. The air would be moving with you, and that creates something extraordinary. Dr. James O'Donoghue, a planetary scientist at JAXA, the Japanese Space Agency, has modeled atmospheric dynamics under extreme rotational change. His simulations show that if the Earth stopped spinning instantaneously, the atmosphere would continue moving, creating a global windstorm with sustained winds exceeding 1,000 miles per hour. For reference, the strongest tornado ever recorded had winds of 302 miles per hour. Hurricane Patricia, the most intense tropical cyclone ever measured, peaked at 215 miles per hour. 1,000 miles per hour is not a wind, it's a wall of air moving at supersonic speed. It would strip the surface of the Earth bare. Trees, buildings, topsoil, animals, people, everything not anchored to bedrock would be scoured away and carried eastward. And yet, the wind is not the worst part. Here's the kicker. The oceans would keep moving too. Water, unlike air, is dense. A cubic meter of water weighs 1 metric ton. And there are approximately 1.335 billion cubic kilometers of water in Earth's oceans. All of it would begin moving east at 1,000 miles per hour. Imagine a tsunami. Now imagine that tsunami is the entire Pacific Ocean. The water wouldn't just create waves, it would reshape continents. Coastal cities would be submerged under miles of moving water. The water would climb up and over mountains, surge across entire landmasses, and eventually, when the Earth started spinning again, slosh back and forth like water in a bathtub kicked by a giant. A 2021 study published in Nature Geoscience modeled extreme tidal displacement scenarios. The researchers concluded that even a 10% change in Earth's rotational velocity would trigger tsunamis exceeding 1,000 feet in height along equatorial coastlines. A 100% change, a complete stop, would be extinction level. That was their exact phrase, extinction level. Let me take stock. In 1 second, every human at the equator would be killed by the initial acceleration. Global supersonic winds would strip the surface bare. The oceans would leave their basins and flood the continents. The atmosphere would begin to redistribute catastrophically. Every building, every bridge, every structure ever built would be destroyed. And we're not done. because the Earth itself would begin to change shape. Now here's where it gets interesting. The Earth is not a perfect sphere. It's an oblate spheroid, slightly flattened at the poles and bulging at the equator. This bulge exists because of the spin. The centrifugal force of rotation pushes material outward at the equator, giving Earth a belly. At the equator, the Earth's diameter is about 27 miles greater than at the poles. If the Earth stopped spinning, that centrifugal force would vanish. The bulge would begin to collapse. The equatorial regions would sink. The polar regions would rise. The redistribution of mass would trigger earthquakes. Not ordinary earthquakes, but planet-cracking magnitude 10+ events along every fault line, every tectonic boundary, every weak point in Earth's crust. Dr. Lindy Elkins-Tanton, a planetary scientist at Arizona State University, has studied planetary formation and internal dynamics. She notes that the energy stored in Earth's rotational bulge is enormous, and its sudden release would fundamentally restructure the planet's surface geography. Mountains would collapse, valleys would rise, new ocean basins would form as old ones were squeezed shut. And all of it, would happen within seconds of the rotation stopping. 1 second of stillness, a planet transformed. Let me take you one level deeper into the quantum realm. No, wait, not quantum, something larger, something more fundamental. Let me go through the charges one more time. We've talked about the wind, we've talked about the water, we've talked about the earthquakes, but we haven't talked about what happens above our heads. The atmosphere would continue moving, but it wouldn't move uniformly. Different layers of the atmosphere would move at different speeds. The troposphere, the layer we breathe, would move at roughly 1,000 miles per hour, but the stratosphere above it and the mesosphere above that would move differently. The result would be atmospheric shearing, layers of air sliding past each other at supersonic speeds. This would create friction on a planetary scale. That friction would generate heat. How much heat? Let me show you why it is anything but small. A 2018 paper in Atmospheric Chemistry and Physics modeled extreme atmospheric friction scenarios. The researchers found that supersonic atmospheric shearing could raise local temperatures by hundreds of degrees within minutes. The air itself would begin to burn, not figuratively, literally. The friction between air layers moving at different velocities would heat the atmosphere to ignition temperatures. Oxygen and nitrogen, heated sufficiently, become reactive. Chemical bonds would break and reform. The sky would catch fire. Now, I want to be careful here. This is not settled science. No one has ever observed or experimentally verified what happens when an entire planetary atmosphere suddenly stops rotating. We are extrapolating from physics principles and computational models. But the physics is clear. Energy must go somewhere, and the only place for all that kinetic energy to go is heat. The most conservative estimates suggest global atmospheric temperatures would rise by at least 5,100 degrees Celsius in the first hour after the spin stopped. The least conservative estimates, the ones that include atmospheric friction heating, suggest temperatures could exceed 500 degrees Celsius in some regions. At 500 degrees, water boils, steel softens, human flesh doesn't burn, it vaporizes. And here's the disturbing part. We haven't even talked about what happens underground. The Earth's core is spinning too, not at the same rate as the surface. There's actually a slight difference, about 0.3–0.5 degrees per year faster than the mantle. But it's spinning. The core is made of iron and nickel. It's roughly the size of the moon. It's spinning at hundreds of miles per hour. If the surface stopped and the core kept spinning, even for 1 second, the differential rotation would generate enormous electromagnetic effects. The Earth's magnetic field is generated by convection currents in the liquid outer core, combined with the planet's rotation. This is called the geodynamo. It's what protects us from solar radiation. A sudden change in rotational dynamics would disrupt the geodynamo. Not permanently, and the core would eventually stabilize. But in the short term, the magnetic field would fluctuate wildly. This is not poetry, this is fact. A 2020 study in Journal of Geophysical Research, Solid Earth examined paleomagnetic records of rapid core mantle rotational changes. The researchers found that even small changes in rotational differential produce measurable magnetic field anomalies lasting thousands of years. A complete stop, even for 1 second, would potentially cause magnetic field disruption that would last for centuries. During that disruption, the Earth would be vulnerable to solar radiation. The protective magnetic bubble that shields us from charged particles would weaken. Radiation levels on the surface would spike. Not immediately. The atmosphere provides some protection, But over the following days and weeks, as the magnetic field recovered, elevated radiation would affect everything from electronics to DNA. Cancer rates would rise, satellites would fail, navigation systems would become unreliable. And all of this, the wind, the water, the earthquakes, the fire, the radiation, from 1 second of stillness. Let me be honest with you, this scenario will never happen. The physics required to stop the Earth's rotation instantaneously would itself destroy the planet. The energy involved would exceed the gravitational binding energy of the Earth itself, but that's not the point. The point is what this thought experiment reveals about the reality we live in. We exist on a spinning rock. That spin is not incidental, it is foundational. Every aspect of our existence, the air we breathe, the water we drink, the magnetic field that shields us, the shape of the continents themselves, depends on that spin. We live in a carefully balanced system that we never see, never feel, and never think about. And that system could be disrupted, not by stopping the spin, but by changing it, slowing it, accelerating it, tilting the axis, altering the orbit. These things have happened before. They will happen again. The difference is timescale. The dinosaurs experienced a world with faster days. The first life on Earth existed when days were only 6 hours long. Future life, if it exists, will experience a world where days are 30, 40, 50 hours long. The spin is not constant. The spin is changing. And we are, each of us, a temporary arrangement of atoms riding on a spinning rock that is gradually, imperceptibly, inevitably slowing down. I find that poetic. Let me zoom back in. We've been talking about extinction-level events, supersonic winds, oceans leaving their basins, the sky catching fire. But let me take you somewhere more intimate. Here's something you've seen 1,000 times. You're sitting in a car. The car makes a sharp turn. You feel yourself pushed to the side, pressed against the door, or leaning into your seatbelt. That's inertia. That's your body wanting to continue in a straight line while the car changes direction. Now multiply that by 1 billion. That's what every living thing on Earth would experience in our 1 second scenario. Not a gentle push. A violent, instantaneous, unsurvivable translation from moving to stationary. When I first understood this, really understood it, I was sitting in my kitchen. It was morning. I was holding a cup of coffee, and I realized this cup is moving at 800 miles per hour right now. This coffee is moving. I am moving. The table, the walls, the air, all of it, moving together, spinning together, existing together in a shared frame of reference that we call still. We call it still because everything is moving the same way. The moment anything stops moving with us, the moment the train hits the wall, everything changes. I think about this now whenever I feel stuck, whenever I feel like life is static, like nothing is changing, like I'm standing still. Because I'm not. You're not. None of us are. We are moving at 1,040 miles per hour. We are orbiting the sun at 67,000 miles per hour. The sun is orbiting the galaxy at 490,000 miles per hour. The galaxy itself is moving toward the great attractor at over 1 million miles per hour. You have never been still, not once, not for a single moment of your entire existence. Stillness is an illusion we've created because we can't perceive motion without reference points, and all our reference points are moving with us. But what does this mean for daily life? Let me show you. Every time you wake up, you have survived another rotation. Every sunrise is evidence that the system continues, that the spin persists, that the delicate balance of forces that allows your existence has not been disrupted. This is not guaranteed. The Earth has experienced catastrophic impacts. It has been hit by asteroids that changed its rotational axis. The impact that killed the dinosaurs didn't stop the spin, but it changed it. The planet wobbled, the climate shifted, millions of species died. We are the descendants of the survivors, and our descendants, if we have them, will be the descendants of whatever survives the next disruption. I don't say this to frighten you. I say this because I think it reframes something important. We spend so much time worrying about things that don't matter. Traffic, deadlines, what someone said about us on social media. Meanwhile, we're riding a 6.6 sextillion-ton rock through the void of space, protected by nothing but a thin layer of gas and an invisible magnetic bubble. And it works. Every day, it works. The spin continues. The sun rises. The coffee stays in the cup. There's a concept in physics called dynamic equilibrium. It describes a system that appears stable, but is actually constantly in motion, constantly adjusting, constantly balancing competing forces. You are a dynamic equilibrium. Your body maintains temperature, chemistry, and structure through continuous active processes. Stop those processes for even a few minutes, and you cease to exist. The Earth is a dynamic equilibrium. Its rotation, orbit, atmosphere, and magnetic field are all maintained through continuous active processes. Stop any of them, even briefly, and everything changes. We are not separate from this. We are not observers watching a spinning planet. We are part of the spin. Our atoms, our molecules, our very existence, all of it is tied to this rotation that we never perceive and rarely consider. When I watch my daughter spin in circles until she falls down dizzy, I think about this. She's playing with inertia. She's experiencing in a small way what happens when your reference frame changes suddenly. Her brain expects one thing and her body does another. That disorientation, that moment of falling, that's the closest any of us will ever come to understanding what 1 second of stopped rotation would feel like, except it wouldn't be playful, and we wouldn't get up afterwards. But here's the beautiful part. We get to spin, we get to ride this rock, we get to experience sunrises and sunsets, which are really just our perspective changing as the Earth rotates us toward and away from the sun. Every sunset is a reminder that you are on a moving vehicle. Every sunrise is evidence that the vehicle made another complete circuit, and for some reason, for no reason we can fully explain, you are conscious to experience it. That is not nothing. That is everything. So what does this mean for you? Let me reframe what we've discussed. We've spent 25 minutes exploring what would happen if the Earth stopped spinning for 1 second. Catastrophic winds, apocalyptic tsunamis, the atmosphere catching fire, the magnetic field collapsing. It sounds terrifying, and it should, in the same way that understanding you're mortal should be terrifying. But here's the remarkable thing. It doesn't happen. Every second of every day for 4.5 billion years, the Earth has continued spinning. Not perfectly. The spin is slowing, the axis is wobbling, the orbit is subtly changing. But the system persists. The same forces that would destroy us if they suddenly changed are the forces that sustain us because they continue. You might think, what's the point? If I can't control the Earth's rotation, why does any of this matter? And that's exactly the wrong conclusion. It matters because understanding changes perspective. Here's what I want you to take away. First, you are moving. Not metaphorically, physically. Right now, at this moment. You are hurtling through space at speeds that would seem absurd if you could feel them. The fact that you feel still is a feature of how your brain processes reality, not a fact about reality itself. When you remember this, the world looks different, less solid, more dynamic, more alive. Second, stability is not absence of motion. It's consistency of motion. The Earth seems stable because everything moves together. You seem stable because your atoms maintain their patterns. Relationships seem stable because expectations are met. Societies seem stable because processes continue. Stability is not stillness, it's synchronized movement. When you understand this, you stop fearing change. Change is inevitable. The spin is slowing. What matters is whether change is gradual enough to adapt to. Third, the ordinary is extraordinary. You made coffee this morning. You didn't think about the fact that the water stayed in the cup because you and the cup and the water were all moving at the same velocity. You didn't think about the fact that the cup didn't fly off the counter because gravity was strong enough to counteract the centrifugal force of rotation. You didn't think about any of it because it's ordinary, but ordinary is just extraordinary that happens consistently. The universe is not obligated to continue working the way it has. The laws of physics are not laws in the sense that traffic laws are laws. They can't be broken by choice, but they describe patterns that we assume will continue based on past observation. Every moment that the universe continues to behave consistently is a gift. Fourth, we are not separate from the system. You are not a passenger on Earth. You are part of Earth. Your atoms came from this planet. Your body is maintained by this planet's systems. Your consciousness, whatever it is, emerged from this planet's conditions. When the Earth spins, you spin. When the Earth orbits, you orbit. When the Earth eventually stops spinning, billions of years from now, when the moon has tidally locked us, your descendants, if they exist, will experience a different world. We are not observers, we are participants. Fifth, thought experiments matter. We will never stop the Earth's rotation for 1 second, but by imagining what would happen if we did, we learn something real about how the world actually works. This is the power of physics. This is the power of imagination, not to predict the impossible, but to understand the possible by exploring its boundaries. This is the most remarkable thing about being human. We can imagine worlds that don't exist, and in doing so, better understand the world that does. Let me take you back to where we started. You woke up this morning, you made coffee, you checked your phone, and the entire time you were moving at 1,040 miles per hour. You will do the same thing tomorrow, and the day after, and for every day of your life. The spin will continue, the sun will rise, the coffee will stay in the cup, and you will never feel any of it. We have traveled in these 35 minutes from your kitchen to the center of the earth, from the first millisecond of a catastrophe to the billions of years of rotation that make life possible, from the physics of inertia to the philosophy of stability. And we've arrived at a simple conclusion. The most fundamental fact of your existence, that you are moving constantly through space, is invisible to you. The systems that sustain your life operate without your awareness. The catastrophes that could end everything are held at bay by forces you never perceive. We are riding a spinning rock through an infinite void, and somehow, against all odds, it works. Now I have a question for you. Tonight, when the sun sets, when the Earth's rotation carries you away from the light and into shadow, will you think about it differently? Will you feel, even for a moment, the fact that it's not the sun that's moving, it's you? Tell me in the comments, what's one ordinary thing you'll never see the same way after understanding the spin? Thank you for thinking about this with me. Stay curious, stay moving.